Welcome to today's Postgrad Insight session. Once again, we're joined by UCL, but today we're joined by the Department of Chemistry to talk about the 6 different MSc degrees offered by UCL Chemistry. There are live elements to this webinar, of course, so if you are looking to ask any questions, looking to have any issues or concerns answered, please pop it in the chat or the Q&A facility. And if you are watching on demand, you won't have that facility, unfortunately, so please email webinars@postgradsolutions.com. Alternatively, I'm sure there will be contact email details in the webinar itself anyway. But for now, I'd like to hand you over to Anna. She's going to be taking you through the next 30 to 45 minutes, joined by a couple of other program directors and her colleagues also. And if you have any questions, please pop it in the chat. I'll be back for the Q&A at the end. Over to you, Anna.
Thank you very much, Gareth. Hello, everyone. Welcome. So excited to be talking to you today about our chemistry master's programs at UCL. My name is Dr. Anna Roffey, and I am an academic in the chemistry department, and I'm also the postgraduate taught tutor. So I kind of run our master's programs. Okay, so this presentation is all about our 6 master's degrees, but I'm going to start with a little introduction about UCL. So UCL is London's global university. That's our strapline, and it's one of the original universities in the UK, so one of the oldest. It's been going since 1826, and it's been pioneering science and education since then. It's a top-ranked university. Currently, we're ranked 9th in the world by the 2026 QS World Rankings, and we're regularly in the top 20 for generally all the world rankings. And we are very proud that we have 33 Nobel laureates, which are amongst our alumni, current and former staff so far. So the chemistry department, why are we special? Why should you care about us? So we are a top ranking chemistry department. So we're ranked 5th in the UK for chemistry. We're consistently one of the best chemistry departments in the UK. Again, that's by the QS World Rankings. We have expert teaching and supervision. So we have 70 members of academic staff who span across a lot of different ranges of chemistry and interdisciplinary science. So we've got a lot of this science covered. And we're a friendly and we're a welcoming department. So it's actually a really lovely place to study, and it's a lovely place to work. So something we're very proud of is that we have a student society for chemistry, which was actually founded in 1876, and it's the oldest running and we think the best chemistry society at UCL. And it's a society that organizes lots of social events, and it's a great way to make friends and meet people. So these are our MSc programs. So I'll just go through them. There's the MSc in Applied Analytical Chemistry. We have Chemical Research. We have Materials for Energy and Environment. We have Materials and Molecular Modeling. Then we have Organic Chemistry, Drug Discovery. And finally, our newest master's, Sustainable Chemistry. Our programs are accredited by the Royal Society of Chemistry, which is the highest mark of quality in the UK. And they kind of span all areas of chemistry. So the analytical chemistry masters is kind of in the physical chemistry area. Then we have the materials for energy environment, which is kind of inorganic. Then we have our modeling masters, which is really in the computational area, our organic chemistry program, which is obviously in the organic chemistry area. But we also have, I've put organic next to sustainable chemistry here, but actually it is kind of interdisciplinary. It does cross over some boundaries, but there is a strong organic chemistry flavor to it. And then chemical research is our kind of pick and mix program. So you can tailor that program to what you want it to be, to your interest in chemistry. Okay, the structure of your year. So these master's programs are quite aligned with each other, and they have a very similar structure. So it's 50-50 teaching and research. The first part of the year is the taught component. So in terms 1 and 2, you cover all of your taught modules. So there'll be core theory and maybe some optional modules. Then we have a literature review module, which supports the research project, but also has some uh, transferable skills in it anyway. And we have a transferable skills module, which prepares you for industry and research. Um, then in the second half of the year, we have your research project, which is a significant 5 month project where you're embedded into a research group and which is led by a member of academic staff, and that will either be computational or experimental, depending on what your program is and your interest. Um, and that goes all the way through term 3 and the summer. So, what about the way we teach and assess? Our teaching is quite tailored to your level. So we've worked very hard to kind of meet your entry level requirements. So we build on the fundamental knowledge that you will have from your BSc or the equivalent degree that you're doing. And we use innovative teaching techniques to keep you interested, to keep you engaged, and to get you to be familiar with the material and be able to apply it in the way that you should for a master's level student. Um, our core theory is taught by academic and industry experts, depending on which program you're working in. Um, so we really draw on the research strengths in our department. So your taught material is going to be really at the cutting edge of chemistry and the kind of chemistry that we do here at UCL. Um, you may have optional courses, which really allows you to kind of tailor your learning, which is hopefully going to keep you really interested. Uh, our assessment for the master's programs is pretty much exclusively by coursework. There are a couple of exams, which depends on which program you're doing. You might have one, but it might also be an option. But on the whole, we work through assessment through coursework. So that means problem sets, case studies, project reports, presentations, posters, lab reports, maybe even blogs, outreach projects. Um, the reason we do this is because it allows for deeper learning. When you're doing your bachelor's degree, you have maybe a lot of exams and there's a lot of memorizing going on. But at master's level, we want you to be able to apply your knowledge. And doing coursework-based assessment means that you really get that opportunity to kind of get deeper into the material and its application. And it also broadens your skill set. So if you're doing presentations, you're going to develop some excellent communication skills. And it also builds your problem solving skills, which is like a key attribute of our graduates. So the value of our MSc degrees. Um, so one of the big bonuses of our offering is that we cover all of chemistry. So we have a wide range of these 6 different programs that covers sort of all specialisms in chemistry. So we can match your interests and your career goals. Real research. So we offer this 90 credit research project, which is a full 50% of your year. So that's one of the largest offered in the UK for an MSc chemistry degree. So you will be immersed in a world-leading research group doing authentic research and getting that authentic experience, which really prepares you to do a PhD or industry research or moving on to your next step. But that's actually quite unique. So we offer that, and many other places will give you a much shorter research experience where you might not have quite the same um, skill set developed. Um, Solving problems. So because of the way that we teach and the way that we assess, you are going to be excellent problem solvers by the end of your degree with us. And also, you're going to be great communicators. So you're going to communicate with impact because you will have lots of experience in communicating complex ideas through written, oral, and other ways. Um, Thinking critically. So again, you will a way that through the way that we teach and assess these programs, you're going to be able to make informed decisions and draw secure conclusions in real world contexts because you're constantly applying what you know to the real world. You're going to build independence. So building the ability to learn independently is a really important part of our master's programs, and it's essential for your future development. So once you are able to learn independently, that means you can learn anything in the future. You can continue your own professional development and growing with confidence. So you will become a skilled, adaptable chemist ready for the future, ready to take the next step. Okay, so now I'm going to go through our master's programs one by one. And I'm going to then hand over to one of our program directors who is going to talk about their program, and then we'll come back. So this is the first program I'm going to talk about, our Applied Analytical Chemistry Masters. And you can see on the right-hand side, there's an image of Dr. Victoria Hilborn, who is the program director. That means she's in charge of that program. She is a very experienced analytical chemist who's worked in academia and industry over many years. And this is her master's. So analytical chemistry underpins many important commercial enterprises, food production, engine development, and it's applied to lots of different disciplines like archaeology, pharmacy, and forensics. This MSc seeks to train the next generation of analytical scientists in the state-of-the-art methods and skills to tackle the challenges of this broad range of applications. This is our most hands-on and applied masters that we offer. There's a lot of learning by doing. There's core theory, but then there's quite a lot of case study and team exercises and project-based work. So on this master's program, you make analytical devices and you measure using them. So it's very applied, which we really enjoy. Career destinations for students who take this master's include going into agriculture and food, toxicology. A lot of students go on to do PhDs, and we've got one of them who's on the call right now, who's going to speak to you later. Energy, medical diagnostics, forensics, environment, pharmaceutical, and policy and government. And actually, one of our graduates, I was speaking to the other day, and she's just gone into regulatory affairs. She's Greek, and she's doing that in Greece, which is cool. Here are some examples of the kinds of research projects that you would do on that program. So here are some images. You can see someone in the lab, one of our students 2 years ago, and this image of the water. So that there was a project on water quality monitoring. The third image is a student working on an analytical device using an Arduino. So they're making air quality monitoring device, I believe, using, yeah, sort of like portable software, portable electronics. And on the right, that was a project to do with indoor air quality monitoring. And underneath that, you can see some project titles from recent research projects that students have been working in. So you can see there's one about bioaerosol analysis, one about indoor air quality, volatile organic hydrocarbon from personal care products. So I believe that's something to do with hairspray, actually, looking at, breathing in the fumes from that. And then the bottom one, analysis of fibers from textile washing and their ice nucleating abilities. Super interesting. Okay, I'm going to move on to the next master's now. So the next master's is chemical research. And this is that program that I was telling you about that you can really tailor to your own interests. So you have a lot of choice, a lot of optional modules, a lot of options to choose from that build on the research expertise in this department, which I explained earlier is quite vast. So you take a bunch of advanced taught courses that you select that cover branches of chemistry that are of interest to you. And then you go on to do this intensive novel research project, giving you hands-on training in the methods and techniques at the cutting edge of that area of scientific research. So it's a great master's. It's a great one if you have a really specific idea in mind, and we have a chemist in the department who works in that area. On the right-hand side, you can see Professor Giorgio Volpe, who is the program director. So he's in charge of that master's, and he's actually a physical chemist, but you don't have to do physical chemistry. You can do any area of chemistry. Career destinations for students who take this program. Many students go on to do PhDs. and industrial research. Manufacturing, they kind of go everywhere: consultancy, IT, pharmaceutical, policy and government, accounting and finance. Um, and actually, I was talking to a student the other day who has gone on to work at AkzoNobel doing research and development. So it is really a great one for opening doors. And on this side, you can see some examples of the research that students do as part of this master's project program. So yeah, it could be computational, it could be lab-based. It really depends on what you choose. And here are some titles, and you can see that, yeah, they really cross the boundaries of, yeah, organic, bio. You've got some computer simulations of water splitting, and then electrochemical performance of a certain co-solvent. Um, just going to cough really quickly. Sorry. Sorry, I'm recording this in December, and yes, it's flu season. Okay, so I'm going to move on to the next master's now, and that is our Materials and Molecular Modeling MSc. So on the right-hand side, you can see an image of the program director. That is our lovely Professor Scott Woodley, who is, yeah, a computational chemist who has been working in the department for a long time. And so this master's is all about the application of computational tools to the current forefront of materials and molecular chemistry research. Um, it involves traditional kind of classical modeling techniques, but also AI and machine learning. Um, they apply these tools to areas such as batteries, photocatalysis, functional materials. Um, and sometimes the projects are actually paired with experimental students as well. So you are like working in tandem on a specific area, so material design and interpretation of experimental results. And this is one of the major research strengths of UCL. So we are world leading in this area, and students who take this master's will have access to the UCL supercomputer, and we'll be doing like high performance computing. So it is a very cool master's. Um, Students who take this master's go on to do PhDs, or quite a lot of them do PhDs, but they can also apply everything they've learned in other areas such as sustainable energy, catalysis, nanotechnology, pharmaceuticals, biomedical materials, and they can go, further afield: IT, consultancy, accountancy, and financial services. Um, Here are some images from the course and some recent research project titles from students. Um, and you can see, yeah, so we've got some great facilities, and you can see the kind of work that students are working across, like materials, bit of machine learning there, and a bit of spectroscopy, kind of band extremer. Okay, I'm going to move on now to our next program, which is organic chemistry drug discovery. So that's our really kind of hardcore organic chemistry program, but it is interdisciplinary. So it is working in drug discovery. So there is definitely a sort of biological kind of element to it. On the right-hand side, you can see an image of the program director, Dr. J.L. Chiapes, who is himself an academic working in that area. And this is a really nice program. It works at the cutting edge of organic chemistry applied to the drug discovery process. So there is a little bit, so there's definitely a good amount of sort of synthetic chemistry, but there's also um, drug discovery sort of computational chemistry. So we combine both elements. Um, there's a strong emphasis on interdisciplinary research. The projects are designed to meet the needs of the pharmaceutical and biotechnology sectors. So this whole program was designed in consultation with industry to meet their needs. So our graduates are very employable. Um, and yes, we can look at some of their career destinations at the bottom of the slide. So a good amount go on to do PhDs. Many of them go on to work in the chemical and pharmaceutical industries. They also go on to things like patent law, um, public sector management, regulatory affairs, and consultancy. So yeah, it's a really good program there. And you can see on this slide some of the research projects from this master's. So these are some images. Most of our research, all of our research projects have the sort of at least a large element of synthetic, organic, bioorganic chemistry. Um, and you can kind of see that reflected in these images. But if you look at these titles from recent projects, you can see the sort of breadth that the students are working across. So prebiotic fragmentation for peptide ligation, uh, molecular biology applications of furan-based DNA cross-linking, and the last one's about antimicrobials. So it's a really exciting area to work in. Okay, I'm going to move on to the next master's now. So this is our newest master's program, Sustainable Chemistry. We're just in our second year now of running this. And this is a unique and specifically developed program in the response to the needs of the pharmaceutical and chemical industries for highly qualified students and scientists with interdisciplinary knowledge of the core concepts and aspects of chemical sustainability and green chemistry to tackle the major global challenges that we face today and tomorrow. So again, this has been developed in consultation with industry. We believe it's extremely timely and obviously some of the issues that come up here are something that we are all quite concerned about. So we're really proud to have this master's to kind of contribute towards the tackling of these issues. It is based at our UCL East campus. So all of our other programs are actually based on the Bloomsbury campus, and this master's is uniquely based over at UCL East, which is a couple miles down the road in Stratford. Um, it's in a brand new building which has brand new facilities, which is it's really lovely over there. And the students who take this, it's reasonably cross-disciplinary, and being over at UCL East means that the students are very close to the other students out there who are also doing like bioengineering and other kind of related programs. So that's a good reason to be over there. Um, on the right-hand side, you can see the program director. That's Professor Daniele Castagnuolo. Um, and he's an academic who works in this field as well. And here are some career destinations that students who graduate from this master's go on to. So definitely going on to PhDs. There's a real sort of green sustainability focus to these careers. So green pharma, biofuels, the recycling economy, green chemical production and waste, sustainability policy, sustainability consultancy. Um, these are the kind of areas that students are uniquely qualified to go into. Um, here are some examples of research projects. So you can see there's some images here that kind of show some research areas that students could work in. So plastic degradation, so that's looking at the sort of recycling economy. I believe they have some projects that use enzymatic plastic degradation, as well as, yeah, so this is one of those, I believe. They also look at other sort of green routes to chemicals, so enzymatic synthesis of flavors and fragrances. And underneath that, you can see some recent kind of areas that students have worked in. So green technologies and green solvents, biocatalysis and biotechnologies, and biomass conversion. So yeah, it's a really interesting program. Okay, I'm going to hand over now to our another academic from UCL. Um, that's great. Yes, Yang Zhu, who is the program director for our Materials for Energy Environment MSc. So I'll let you talk about your own program, Yang. I'll pass to you.
Hello, everybody. I'm just to use a couple of minutes to give you an overview of the master's program, Materials for Energy and Environment. in the department. So my name is Yang Xu, and I am the program director for this master's program. And as you can tell from the name, this program is designed to focus on materials, but not just every materials, but materials that have very high, very strong relevance to energy and environmental applications. Um, this is a program that branches out to a lot of different applications where material is the focus. We try to understand how material works, how you can make materials working better. And this is ideal program for you if you wish to learn skills in energy and materials chemistry in order to participate in the emerging challenges to meet climate change targets. There will be a few examples of the research projects later on where you can have a taste of what kind of research focusing on materials we're doing here. In terms of career destinations, again, because you will learn a lot of transferable skills and knowledge of materials for these very climate change related areas. So a lot of our students go on doing a PhDs after the master program. And some of them are working in renewable industries such as PV, batteries, sensors, devices. There are graduates working on energy analysts, for instance, consultancy companies looking at the supply chain of the materials for a certain area. There are students going for engineering, for materials development and analysis, also policy aspects of energy and environment. Energy transition consultancy is another destination. Plus, as you have the general background of energy and environment for materials, some of our graduates go on for doing environmental laws. Next slide, please. So as Dr. Rothi has introduced previously, the structure of this MSc program consists of two major components. The first one is top modules, and the second one is a research project. Because, once again, this is a materials-focused program, the top modules are giving you the background of material knowledge. You will learn the theories of how materials are made, how they work. And after you finished all your top modules, you will go on taking a research project that take your knowledge of materials to another level, a further step where you will try to make the material, synthesize the materials, use different fabrication techniques, and you will test the materials in different devices to assess their performance, and you will learn how you can optimize the performance of the materials through the synthesis of the material. Because the combination of top modules and the research project throughout the whole program, you will learn quite a lot of different soft skills. For instance, scientific communication, time management, academic writing, data analysis, problem solving, collaborations, working in a team, and trying to explain your science to a general audience. All these skills are very important to enhance your employability after you graduate. Next slide, please. So on this slide, you are seeing a few research projects that gives you a taste of what we are researching here, taking on a very strong presentation of the department in the research of energy. We have a lot of projects related to energy. For instance, on your left-hand side, you will see potassium vanadium pyrophosphate, which is a very, very promising materials that can be used in potassium ion batteries, which is one of the next generation batteries. You all know batteries is the topic that won the Nobel Prize for Chemistry in 2019. In the middle, This is an example of electrocatalysis. Catalysis is another very important front in the energy and environmental area. Here you see students are looking at testing different substrates, how it affects the performance of the zinc and nitrogen-doped carbon composites. And we are using this composite to reduce nitride, which has a very strong relevance to environmental improvement. On your right-hand side, you see a very nice structure of metal organic frameworks. This is another very upcoming and important topic, which won the Nobel Prize for Chemistry right this year in 2025. So we have projects that involves synthesize, understanding the structure of metal organic frameworks and trying to improve their performance using for sensing applications. So you get the taste that we have a lot of projects that are very applied, that are very relevant to the very forefront of the energy and environmental research areas. So now I'm going to hand over to Judy, who is our alumni.
Hi, everyone. I'm very glad to be here today. I am a first-year PhD student in the UCL Chemistry department. I completed MSc this September with Professor Stephen Howalk. My master's research topic is understanding the nanopore formation of antimicrobial peptide niacin. MSc program provided me with a strong foundation for my current research work, including data analysis, lab work skills, and oral presentation experience. Most importantly, it gave me many opportunities to speak with different research groups and learn about their ongoing projects, which is incredibly valuable for the students who are considering a PhD in the future. I hope you will join us and enjoy an excellent study and research experience at UCL Chemistry. Thank you.
Thank you so much, Judy. Thank you. Yes, Judy was on the Applied Analytical Chemistry Masters last year, and I taught her on that in the lab. So poor Judy had me as an actual lecturer. Here are a couple more student testimonials from over the years. From different students on different programs. So we've got Eleanor, who was on the Applied Analytical Chemistry Masters at the top. And actually, she is the student I mentioned earlier who's now working in regulatory affairs. And yes, she says, I've really enjoyed the Analytical Strategies course where I was able to enhance my transferable skills and critical thinking and apply my knowledge. Then we had a student from the molecular modeling program, Tongi Kang, who said it is nice to make new connections with new people and have similar academics to me, interests to me. Without any doubt, studying at UCL is probably the best investment for my whole life, which was a lovely thing to say. And then we have Rui Tang, who was on Professor Yang Zhu's course, Materials for Engineering Environment. UCL is a world-class university which enjoys a high academic reputation. I want to study with inspiring people and contact with frontier ideas. The setting of the program, a full year combining teaching and research, is exactly what I want. Okay, so that's what we do and how we do it. This is some information about application. So if you are interested in applying for one of our master's programs, the deadlines for the next cohort are the 28th of August 2026 if you are a UK resident, or if you're EU or overseas, then the deadline is the 26th of June 2026. You apply through the UCL application portal, and you just need a personal statement, a transcript, and one reference. And our entry requirement level is a 2-2. So you need to eventually achieve a 2-2 or equivalent. And there is funding available. So I've put a QR code in the bottom right-hand corner that goes to the UCL funding page. So there's a UK Masters loan, but there are also UCL bursary and scholarships. So that are available for everyone. So there is some information there at that link. And finally, this is how to contact us. So again, I'm Dr. Anna Ruffy, the postgraduate taught tutor. I'm supported in my role by the wonderful Momora Seatle, who is our teaching and learning administrator for the master's programs. And you can get both of us by emailing masters.chem@ucl.ac.uk. And the QR code on that page will take you to our homepage for the master's programs on the UCL website.
Anna, thank you for that. Really great. I'm hoping, presuming that's your last slide.
It's
Before I move on, thank you. To Yang as well, and from the alumni student also, thank you very much. Can I start with a couple of questions which I would have both yourself, Yang, and Anna. What's the education like? What's the classroom sizes like? Because there are many universities that you go to, and although chemistry on the face of it might seem like quite a niche subject, it is still one of the more popular ones around the world. So are they huge class sizes, or are they quite intimate? Therefore, every professor, every doctor knows their student's first name, knows them quite well, or is it, a classroom of 300 students? Anna, if
I
I can
can,
start with you.
yeah, I can take this one. Yes, it is quite intimate. So our class sizes for the different programs range from about 10 to maybe 25, 30 at the absolute outside. But even with our students where there are 30, the academics do know all of their names. And actually the largest program we have is the molecular modeling program, which is run by Professor Scott Woodley, and he definitely knows all of his students' names. And yeah, he spends a lot of time with them in those computer labs. So yeah, we have good class sizes, I would say.
Yeah, and Yang, were you kind of further that one? Obviously, in the heart of the classroom, do you know everyone? Does everyone know you quite well as well? Presumably that helps because that goes a long way as well, doesn't it?
Yeah, so another thing I want to add on is as a program director, we're also the academic advisor of our students on the program. So we have regular interactions with the students on the program, and we get to know each other quite well throughout the program.
Excellent. Um, Also as well, I want to talk about, one of the questions that came in is for someone that's unsure on the MSc to choose. What pathway, what should they be looking at in terms of what's important to them? Is it what their speciality is? Is it what they enjoy? Is it the best potential for a career? Anna, what would you say to that first and foremost?
I would say it's probably a combination of all three. I'd like to say just go with your passion, but we live in the real world and everybody needs to think about their future and think about their career. Um, I would say all of our master's programs do make you eminently employable, so there's really no wrong answer, but you should try to follow your interest and your passion. And I mean, if you have excellent grades in organic chemistry and you love organic chemistry, you've got a choice of two. But if you have excellent grades in inorganic chemistry and you're not really great at organic chemistry, going for the organic chemistry masters is not a great idea because there will be a big catch up right at the beginning. It's doable, but yeah, you have to kind of think about where your talents lie and where you're heading in the future.
Yeah, Yang, do you want to further? And actually, if I can ask a question off the back of that, what stage should students start thinking about what they want to do with their career? Because, like Hannah said, we live in the real world. Obviously, we'd all love to do things that we're passionate about and perhaps that we enjoy. But at what stage during their studies, perhaps during their employment, should they go, right, this is what I need to do?
I think in the early stage of undergraduate, students are slowly developing their interest in different areas, or in this case, areas of chemistry. That's a good indication to start with. But by the time they start applying for a master degree, they probably already have a better idea I think not only in the area of chemistry, but a specific area of job markets. So the master programs, as Anna just said, is kind of a test the trial, follow your passion, and you carry on a research project that you are obviously interested in. And I think by the end, towards the end of master program, most of our students have a quite good understanding of what they want to do in the future.
Anna, if I can come back to you on the chemistry kind of subject and theme, because there will be many students that are watching that perhaps don't know that chemistry is for them. Obviously, the first thing that springs to mind for me for chemistry is the pharmaceutical kind of pathway. But obviously, there's so many things. Forensic science probably falls into that. Pharmaceutical, like I've mentioned, obviously quality control, presumably things like that. All of these things can fall under that chemistry remit, can't they?
Yeah, absolutely. I mean, you saw the careers sort of slides I had for all the different programs. Like, obviously, there are many transferable skills, and actually, us graduates can come out and not even do chemistry related jobs because they have these, they're very numerate and they're very analytical. So they can go on and do, work in finance, work in consultancy. But from a chemistry perspective, the sort of the training they get here, especially in the programs like Yang's program, in materials science, like you can go off into all sorts of different companies working in the, alternative energy market, materials for solar set. Like it's a really wide industry that you can kind of go into from these programs. I'd actually know a graduate from the modeling program who did a PhD, did some different postdocs, and then went on to work in a cryptocurrency company, blockchain company. So
Yeah.
yeah, you can go anywhere.
That sums it up beautifully, I think. I think not just chemistry, but all other subjects that UCL will offer, but all over the country as well, because it's so broad now that you can, widen your horizons to. So that's a great point. Yang, if I can come to you at this point, if we
Mhm.
can talk about the career post-graduation opportunities. I know UCL very strong on career services and, links to businesses, not just within London, but globally as well. How important is that to a student when they're looking to study their chemistry degree or anything? It might just be that they're looking to come to London, UCL specifically, that actually there are so many links. It's unreal. It's crazy, isn't it?
Yeah, so we do have a quite good support of our students in terms of career navigation in the department. Every program director is the academic advisor to their students on the program. So the program director is usually the first contact point if students have, queries about career navigation. So we're very happy to talk to students on this with this regard. And in our department, we have a sitting advisor specifically appointed to work with students, help them with career choices and understanding. They can book appointment with this advisor in the department. At college level, we have UCL Career, which is, I think, a group of people who are helping students across UCL. And as a chemistry department, we buy in for extra appointments for our students in our department so they can go in, make an appointment, and have a conversation with career advisors at UCL level. So we have, this multiple layer of support for students in terms of career.
And how do you support students that will inevitably, some of them looking to transition to a PhD?
Yeah,
Is that an opportunity? Because obviously there'll be many students that will go, right, need to get a
yeah,
job now, because that is
yeah.
kind of how it normally goes. But PhDs, what's the next steps?
Yeah, there's a lot of students who are looking at doing a PhD. I myself was often asked by my students in terms of what are the PhD opportunities around here at the UCL or in the UK and also around the world in different other countries. So I normally provide a lot of information with students because I have a good network around the world, and also because of my own academic path, I've worked in a few different countries, so I got a little bit of knowledge about how the PhD system works, how to apply in those countries. I student booked appointment with me. We sit down, we talk it through, and sometimes I even, introduce my students to my colleagues overseas if there are PhD openings. Um, there's also, I think, we in department we run an event opening to all our undergraduate and PhD students where all the PhD opportunities at UCL and department are introduced, so students can have a better understanding and start preparing earlier.
Yeah, and in terms of the actual opportunities to kind of present their research or to publish it, is that an opportunity as well for students?
Of course, of course. I think the priority of doing a research project is to have this authentic experience, to have a taste of doing research in a lab, just like a PhD student. Obviously, depending on how the research project progresses, if it progresses well at the end of the project, there are very promising results that can be written up. And obviously, the master student will be a major contributor to the project and to the paper.
And Anna, if I can come back to you at this point, how flexible are the MScs? Can a student kind of, I don't like this word, but float between one and the other? Can they flirt with one and then kind of go, right, this isn't for me, this is for me? Is that opportunity there?
To some extent, at the beginning of the year, we do have that ability because a lot of the master's programs will have some crossover right at the start, but eventually around 4 weeks in, kind of need to commit because there's core theory that each of the different masters has a different kind of core theory, and that kind of you need to kind of get into that at some stage.
Okay.
Sorry, just to
Go on,
follow
go
on what Anna just said, for students who try to switch programs, if they, inevitably miss a little bit core modules at the beginning of the program, every lecture is recorded, so there's an opportunity for students to catch on by
That's very true.
watching the lecture videos.
Yeah.
Yeah, well said indeed. Anna, Yang, thank you for your time. Really appreciate that. Thank you. I appreciate you taking the time out of your very busy schedules to catch up with us today. If anyone has missed anything today, please, look on demand, go on postgrad.com, look on our Postgrad Insights channel. Alternatively, we'll reach out to you with a copy of this video. It's been a very popular session. Over 100 of you actually registering and signing up for this webinar in December is great. So if anyone has missed anything, you will receive a copy in your inbox very shortly over the next 2 or 3 days. But for now, Anna, Yang, thank you for your time. And to the alumni student in the background, of course. Thank you. Take care.